The fifth video in this section, absolute value 5, and we're on to the third video on graphs, absolute value graphs. And I'm calling this a mix of graphs because we have various techniques here. All the examples are taken out of the textbook. So here we are, page 77, examples 6a and b, and there is the link to get to the actual exercise. If I click the link, I'm going to go on to it. Let's log myself in. And there we have the absolute value graphs, example 6. Let's get back to the graphs now. So we're starting with f of x equals absolute value of x over x. So we're going to revert to the definition of absolute value, which we have to do in many a case in this sort of instant. So there's our definition. There's the definition there. Absolute value of k is k, status quo, if k is greater than or equal to 0. Negative k, in other words, change the sign, if k is less than 0. So we have x over x if x is greater than 0. Notice that the absolute value of x is x. I haven't put greater than or equal to. There's a greater than or equal to. There, not here, because we have the resultant division by 0. We can't have that. We can't have 0 over 0, so therefore x is only greater than 0. And then we have the sign change, negative x over x if x is less than 0, which gives us that. So it's two simple graphs. There we are. X greater than 0, to the right of the y-axis, we've got f of x equals 1, y equals 1. And to the left of the y-axis, for x less than 0, we have y equals negative 1. Notice the circles to exclude x equals 0. B, g of x equals the absolute value of x squared minus 1. So here by definition, status quo with brackets, if x squared minus 1, the contents of the absolute value is greater than or equal to 0. And change the sign of it with brackets if x squared minus 1 is less than 0. So we have x squared minus 1 and x squared minus 1 to be less than 0, x must be less than or equal to minus 1 or greater than or equal to 1. So for example, if x was negative 3, negative 3 squared is 9 minus 1 would give me 8, which is greater than 0. And of course, any positive number greater than or equal to 1. For x squared minus x squared plus 1 to be negative, or in fact what we've done is we've simplified that. For x squared minus 1 less than 0, and for that to be the case, x squared must be less than 1. So x is between negative 1 and 1. Sorry, in fact the or equal to shouldn't be there by the definition, but it doesn't matter too much. So there's the graph of y equals x squared minus 1. Pretty straightforward parabola. And there's the graph of y equals negative x squared plus 1. Notice coded by the colors, so you can see which is which. Now, for x less than or equal to 1, minus 1, or x greater than or equal to 1, so I've drawn those vertical lines at x equals negative 1, x equals 1, and it's less than, so it's on this side, the left side, or it's greater than, so it's on the right side there. That being the case, we're going to throw out this bottom half of the curve because it's between the two. Going on to this one, between x is between -1 and 1, which means it's now that section only here. So we're going to have to throw out those two arms on the side there. So in fact, here's our graph coming down here, then it takes a shift upwards, and then there. Notice very faintly you can see the original graphs coming down here. Now we're going to use reflections. As it says, generally this is shorter than use of definition, and you'll see how much so. So there, y equals the absolute value of x squared minus 1, the same one as before. There's our graph of y equals x squared minus 1. There. Now, f of x is greater than or equal to 0, as it cannot be negative. This is absolute value. So therefore it's greater than or equal to 0 as it cannot be negative. So therefore this is shaded out. This shaded out portion shows that section of the graph we can't have. When x squared minus 1 is less than 0, its sign is changed by an absolute value, by the absolute value. So in this section, the sign has been changed. So we're not going to have -1. We're going to have its sign changed to 1. So we're going to reflect the section of the graph below the x-axis to above the graph. Just once more, there's the shaded area where we can't have the graph. So it's reflecting up to the other side there. And there is our graph of f of x equals the absolute value of x squared minus 1. Another example, g of x equals negative the absolute value of x squared minus 1. Well, there's the graph of negative of x squared minus 1. X squared, the absolute value of x squared minus 1 can't be negative, so therefore put a negative sign in front of it. It has to be negative or 0. It cannot be positive. If you have negative of an absolute value, it cannot be positive. So therefore this section of the graph is now not allowed, this section here, because there the y is positive, the g of x is positive. So we're going to reflect it down to that side, and there is our graph. Quite a bit simpler than using definitions. So now we have f of x equals absolute value of 2 over x. Well, there's y equals 2 over x. But now this cannot be negative. It's got to be greater than or equal to 0 because it's an absolute value. And the absolute value is a positive value. So therefore this section we cannot have. But we still have x values here, so what we're going to do is we're going to reflect this up to the top. Let's go back a step. There we are. From there, that's going to reflect up. And there we now have our graph of f of x equals absolute value of 2 over x. Here's an exponential graph. So g of x equals 2 to the x minus 2, all inside the absolute value sign. So there's the graph of y equals 2 to the x minus 2, the normal graph of y equals 2 to the x minus 2. It's the graph of y equals 2 to the x shifted down 2, in fact. So instead of going through plus 1 as all the exponential graphs straight y equals a to the x go, it's going through minus 1. Its asymptote now is y equals minus 2 instead of the y-axis. Y equals minus 2 instead of the x-axis, which is y equals 0. Now it cannot be negative. This cannot be negative because it's in an absolute value sign. So therefore this section we cannot have below here. So we're going to do a reflection of this part of the graph up to the top. There we are. And there's our graph of g of x equals 2 to the x minus 2 in an absolute value sign. Sorry, forgot off the label g. We're just going to do one using translations. This is textbook, page 82, example 8. There's just a single example there, y equals 2 over x minus 2. We've been using reflections. Now, translations use shifts, left, right, up, or down. Here we go. F of x plus 2, that's f of x up 2. F of x minus 2, f of x goes down 2. F of x plus 2 goes 2 left, f of x minus 2 goes 2 right. And just to remind you of this paradox here, when it's f of x plus 2, it goes 2 left. That's because x needs to be 2 smaller to achieve the same result. If I'm talking about f of 5, and now I want f of x plus 2 to end up with the same value as f of 5, x has to be 3. 3 plus 2 will give you the 5. And similar there, x needs to be 2 larger to achieve the same result. So there we are, we sketched y equals 2 over x, f of x equals 2 over x in example 7c. So let's go straight to that sketch. Just in case you're getting it twice. In order to obtain that using translations, it's that graph minus 2, so it's going to go down 2. So it's going to shift down 2 units. There we are. Instead of having the x-axis as the asymptote, it's going to have x equals negative 2 as the asymptote. It just so happens that it does go through negative 1 and 1, and labeled f this time. I guess strictly speaking, I should continue those up there. And then that's the end of the absolute value graphs. I will supply you exercises from the textbook with the screen captures.